I'm glad you're here today. I'm in my lab outfit because we're in the chemistry lab today. As part of the week on math, we are going to talk about what it's like to be someone who works with molecules. When a chemist works with research in molecules, they have to understand how the molecules act, and they do that best by being able to count them accurately. Molecules of different sizes and shapes act differently in different circumstances. So we can use that in all kinds of research, maybe for food, but also for medicines and vaccines, which is what we need today. So what I want to show you down here first is that I have some samples of salt. Maybe you've done some experiments with salt before, because salt comes in different sizes. This would represent fine salt crystals that are tiny, and these would represent an average size salt crystal, and these would represent the large coarse crystals of salt. And as you can see, this is very different for each one. The size is different. And how would we figure out how that might affect us? One way is to pretend that you can test our taste buds with these different sizes of salt. So right here I have for you, this is a sample of our tongue and the taste buds that are on our tongue. Each molecule of salt is broken down when we eat it and might touch a different taste bud. The number of taste buds that each bite of salt touches would give us more flavor. The more taste buds it touches, the more flavor we would get out of that salt. So that can help us figure out, would we want to use fine, regular, or coarse-grained salt to get the most flavor out of our food? Let's try this experiment now. As you can see, I've got tiny pieces of this. Let's say this is 1 crystal of salt, and if I just, I'll be back. No, it's not dice. If I just drop it any place, how many taste buds can now 1 molecule of salt touch? Wow, 1 taste bud. So maybe 1 fine grain of salt wouldn't work, but when we chew it up and then it breaks down into its molecules because of the acid in our mouth, in our saliva, oh my gosh, look how many taste buds it can touch now. 1, 2, 3, 4, 5, 6. We'd get more flavor out of that once we ate it. Now, let's see what happens when we use regular salt. So this represents 1 molecule of salt, and it looks like it might touch 4 taste buds if we hadn't chewed it. Now we break it down, our saliva breaks it down, we're chewing, and how many taste buds will it touch? It touched 4 before we ate it. 1, 2, 3, 4, 5, 6, and if those touched any, it might be more. So it's definitely more with a regular grain of salt than after we chew it. Now, this is a piece of coarse salt. How many taste buds will it touch before we even eat it? 1, 2, 3, 4. That was the same as the regular salt, the way it fell. But if we chew up that coarse grain of salt, how many will it touch? 1, 2, 3, 4, 5, 6, 7, 8. And that one might touch another one. So you would keep track of how many it touched each time and decide which would be better to use. So the chemist does the same kind of work in the lab. He would do experiments over and over and over to get an average, and then he'd know what would be the best size and shape of a molecule to use for medicine, or vaccines like we're working so hard to develop now. So I have this and I'll post it up to go with the worksheet, and you can certainly try this out if you have blocks of different shapes. It's kind of fun to pretend you're playing with taste buds. And I'll see you again soon. Bye.